Hello and welcome. So we are still, believe it or not, in the solving equations with radicals lessons here, again where the idea is to try and isolate the radical and then cancel it out using an exponent. We solved a bunch of equations so far, and now we are going to just multiply some radical expressions, okay? Kind of a little bit of a different kind of thing. So let's go ahead and do that. Looking at this, right, you can see that it looks awfully like two binomials being multiplied together, and in fact that's exactly what we can multiply this like. So it'll be root x times root x. It'll be root x times minus 2. So root x times root x is just root x squared. And then the root x minus 2 is minus 2 root x. And then the plus 2 times root x and the plus 2 times minus 2. So plus 2 root x, and then 2 times minus 2 is negative 4. Okay, when you square a square root, what happens? They cancel, and you're left with just an x. These are like terms, right? And what do they simplify to be? Well, it's going to cancel out, exactly, because they're exact opposites of each other. So these are gone, and we just have the minus 4. So there's our answer, x minus 4. Okay? Why don't you go ahead and try number 14 and see what you get. It's very similar to number 13. Okay, so number 14, hopefully you paused and tried it. Again, if you didn't, please do that. It's really helpful for you to try this on your own. So for number 14, we'll do root x times root x times 4. So again, root x times root x is root x squared. Root x times 4 is 4 square root of x. 4 times the square root of x is another 4 square root of x. And 4 times 4 is 16. Okay, square the square root there, we end up with just x. Do these cancel out this time like in the past? No. Okay, these actually can combine together to make a plus 8 times the square root of x. And we have the plus 16 there too. And is there anything else you can combine together here? Like, for example, can the 8 and the 16 go together? The answer is no, because this 8 has a root x attached to it, whereas this 16 does not. So they are not like terms. So we're done. That's the best we can do. Okay. 15, slight variation here in that the whole thing is underneath the square root, and this whole thing is underneath the square root. In fact, we are multiplying identical components together here. So what does that really mean? Well, when you multiply something by itself, it's the same as writing x minus 5 squared, root x minus 5 squared, right? And when you square a square root, what happens? It cancels out. And we're left with just x minus 5. And there's our final answer. Okay, let's move on here. Okay, another kind of turn corner here. In these examples, we're asked to rationalize the denominator in each expression. That means to get rid of the square root in each expression. Okay? I'll rewrite expression so the fraction has a rational expression in the denominator. Okay, so what do we do? How do we get rid of it? If you recall from past times we rationalized, for example, if we had like 2 over the square root of 3, okay, we multiplied the top and bottom by the square root of 3. Why? This creates a perfect square in the denominator, right? We'll get 2 root 3 in the numerator, but then root 3 times root 3 gives us root 9, which simplifies to 2 root 3 over 3. And then it's rationalized because we have a nice rational number in our denominator. Okay, so for here, right, same kind of idea. We'll multiply the top and bottom by root x minus 9. Okay, why? Well, so the x minus 9 times the root x minus 9, we can't really do too much with that, so we'll just leave it as this, x minus 9 times the square root of x minus 9. But then over, what's that going to create? It creates a perfect square, right? It's root x minus 9 multiplied with itself, so it's squared. And the square root will cancel, leaving us with x minus 9 in the denominator, and then x minus 9 times the square root of x minus 9. Now, if we look a little bit more here, we can see that, wait a minute, what can we do with these two terms? They're exactly the same. And it's a product here, right? So we can cancel them. And we're left with just the square root of x minus 9 as an answer. Okay. Want to be a little bit careful here with our answer because this problem, right, this expression, you can't plug a positive 9 in because you get 0 over 0. But this expression has no problem with plugging a positive 9 in, right? You plug in 9, you just get 0. So we're going to be a little bit careful. These two things are equal as long as x is not equal to 9. Okay? Because this one, if x is 9, you get 0 over 0. But this one, if x is 9, you just get 0. So they're not exactly the same when x is 9. All right. Letter B, we'll do the same kind of thing here. This is a little bit different though. If I were to just multiply the top and bottom, for example, by like a root x, okay, the root x would distribute to both terms, and I'd have x root x minus 9 root x. But then here this root x would also distribute, and I'd have root x squared plus 3 root x. This would simplify to just x, but we still have a square root of x in our denominator there. And that is a problem because we didn't get rid of it. And if I multiply by another root x, well then this term will get the root x and this term will lose the root x. So in other words, we have to do something different here. And the answer is we're going to multiply by what is known as the conjugate. So instead of the root x plus 3, we'll multiply by root x minus 3, and then root x minus 3 in the numerator too. What does that do? Well, let me show you here. We multiply in the denominator. It's going to be root x times root x, so it would be root x squared, and then it'll be minus 3 root x, and then plus 3 root x, and then, whoops, and then 3 times negative 3, which will be 9, negative 9. Crikey. Okay, like so. And then in the numerator, okay, we have to distribute this out too. I'm just gonna leave it like this for right now. Okay, so x minus 9 times root x minus 3 over x, and then the minus 3 root x and the plus 3 root x cancel, and we have a minus 9. Okay, and hey, what do you know? The x minus 9's cancel again, and we have root x minus 3 as our final answer. Okay, for the simplification. All right, so there we go. And we'll stop there, and in the next video, we'll take a look at exercises 16 to 18.